Hi, Assalamualaikum. My name is Nur Hayati. Today, my team and I going to present for the topic in operating system is paging concept. This is my team member, Intan Nur Shahada, Atira Nabiha, and this one is me, Nur Hayati, and Nurul Nazira. For the introduction in paging concept. Paging concept have the memory management technique used by operating system to efficiently handle allocation of physical memory to be processed. It allows the system to avoid external fragmentation and makes better use available memory resources. So in paging, the logical address space is divided into fixed size blocks that called pages, while the physical memory is divided into blocks of the same size that called frames. When a process is loaded into the memory, its pages are mapped to available frames which may be scattered throughout physical memory. Okay, for the paging concept, it has advantages and disadvantages. So we're going to look at the advantages. For the number one, it eliminates external fragmentation. Number two is simplifies memory allocation, and number three is allow processors to use non-contiguous memory. So for the disadvantages, the needs for page and tables. The second one is a slower access due to the address translation, and the last one is overhead when handling large address spaces. The problem statement in the paging concept in operating system. Modern computer system execute multiple processes concurrently that require efficient memory management to ensure optimal performance and system stability. So one of the core challenges in memory management is allocating physical memory to processes while avoiding fragmentation and ensuring fast memory access. In a traditional memory allocation technique, such as contiguous memory allocation, suffer from external fragmentation and inefficient memory use. These issues become more pronounced as processes dynamically grow or shrink during execution. To address all these challenges, paging is introduced as a memory management scheme that eliminates external fragmentation. By dividing both physical and logical memory into a fixed block, pages, and frames. However, this implementation of paging introduces its own set of challenges. It increased overhead due to maintaining page table, slower memory access caused by address translation, and limited size of pages table in system with large address spaces. And last one is a page replacement decision in case of insufficient memory physical. So this one is the problem statement. Next, my team going to present. Thank you.
Assalamualaikum. My name is Nurul Nazira binti Nazri. Today I would like to present about my part in the paging concept. Okay, the paging concept is related work in our surrounding. So the paging is a cornerstone of modern operating system. It allows for efficient memory management, visual memory implementation, and also process isolation. Paging is a revolution, has involved numerous related about word and investment. So the first related word of paging is about historical development and foundation. So before paging, programmers often use manual as yearly system and manual overlay. So the second of history of paging is it used the Atlas computer, and then it's about segmentation. Segmentation is some early system like Multics is a combination segmentation and paging, and it's a call page segmentation. The second related words of paging is about core paging concept and mechanism. So, paging is a primary mechanism for implementation visual memory. It's allow a process to use a logical space that can be much larger than the physical RAM available. The second is a page and frame, and the third is a page table, which in the OS maintain page table for each process. And the last one is page faults. What is a page fault? When a process tries to access a page that is not currently in physical memory, these faults will be occur. And the next point of related word of paging is about page table optimization and structure. So it's about translation, look aside buffer, is a multi-level paging, and evented page table. So instead of having a page table per process, the evented page table has one entry for each physical page frame. And then the next related word of paging also is about page replacement algorithm. It uses a FIFO, first in, first out, LRU, least recently used, optimal page replacement, LFU, least frequently used, and clock algorithm. And the last of related word of paging is about advanced paging technique and modern development. So it's called demand paging. Why is it demand paging? Page are loaded into memory only when they are actually represent, minimizing initial loading time and memory usage. And then it's called pre-paging, copy and write, memory map file, large page, and visual machine.
Everyone, my name is Intanusha Pinchi Ambrine. My metric number is SX240234EC3H03. Today, we are going to explore one of the most clever tricks your operating system used to manage memory. It's called paging. But instead of diving straight into the technical jargon, we will use a fun analogy, a library. By the end, you will see how your computer memory works just like a librarian manages books. Let's get started. Okay, before we start, imagine your computer RAM is like a library with limited shelf space. Every running program needs book data from this library constantly. But what if the shelves are full? The OS cannot just buy more shelf, right? It needs a smart system to share this space efficiently. There's paging come in. Paging breaks memory into big size block called pages. Think of them as a standard size book box. This way, the OS can neatly organize data just like a library organized book. Let's go the library analogy. Okay, this is all book is represent to the memory page. Bookshelf represent the RAM. It is a limited size, and catalog system is a page table track where book are, and librarian is a memory management unit (MMU). So in the catalog we have operating system, computer unique, algorithm, database, machine, library, machine learning, web development as an example. Now we will test our library analogy. What happens when you request a book? If it's on the shelf, it's great. For example, we have database system in bookshelf. That's a page hit, but it's not page fault. So I want book machine learning, but not have in the bookshelf. So the library must fetch it from the storage. So you can see we have a book machine learning. Okay, so what if shelves are full? Handling page fault. This is where page replacement are gonna shine. Let's test two strategy. V4. First in, first out. The library remove the oldest book. Simple, but what if the book is still popular? We will choose LRU, least recently used. The library must remove the least recently read book. Smarter, but requires tracking. So, for example, okay, this is a full bookshelf. So I want to book algorithm. Okay, so we will use LRU, remove computer network and fetch algorithm fault. We will remove computer system and replace with algorithm. Okay, in our solution, LRU reduced page fault by 20% compared to before. Just like a librarian who remember which book are actually being used. In real world impact, why does this matter to you? Even notice your computer slowing down when you open too many tabs. There is thrashing. The OS is drowning in page fault. Efficient paging keeps things smooth whenever you're gaming or running quick. And here fun adds SSD add like a faster storing room for our library. Reduce fetch time. Upgrade your library and your OS breathe easier. So that's all for our library analogy. Thank you. Feel free to try our simulation at GitHub link and happy bookkeeping to your OS. Thank you.
I want to elaborate result and discussion paging concept in operating system. So paging is a fundamental memory management technique in OS with a profound impact on how computer utilize the memory resource. So the result of implementing paging is the first one is efficient memory utilization and reduce external fragmentation. And then the second is implementation of visual memory and enhance of multi-programming. And then the last support of demand paging on copy on write.
Hi, I'm Atira Nabiha binti Isha, and it's my turn to explain about future words for paging concept. So, as a general, future words refers to the plan, next steps, improvements, or research direction proposed after completing a project, study, or presentation. It identifies gaps, limitation, or opportunity to extend the current work, ensuring progress and innovation. For future work paging concept, first we enhancing paging algorithm, explore AI, ML based page replacement strategy. Example, predictive page faults avoidance is investigate prediction models to anticipate page faults, reducing latency by preloading critical page. Example, reinforcement learning by dynamic page replacement. So second, real-time system. Real-time optimizing paging for latency sensitive application. Example, autonomous vehicle. So tailor paging for autonomous system where microseconds matter, minimizing jitter through deterministic paging schemes. So third, security hardening, security extension. So develop mitigates for side channels attack. Example, inscription page tables to protect sensitive data in shared environments. Address paging tables vulnerables, side channel attack like Spectral. So next, hard integration. Lev- Leverage emerging hardware (NVM) obtained to reduce paging overhead. It is known as a hybrid memory architecture tool, like combine paging with segmentation or newer parad- paradigms. Example, persistent memory to balance flexibility and speed. Lastly, scalability improvements. Research hybrid paging schemes. Example, combining paging with segmentation. So why is it matters for future work for paging concepts? These steps bridge gaps in performance, security, and scalability for next generation system from cloud servers to edge devices. So for the conclusion, we can conclude that paging is a fundamental memory management technique that enables first, virtual memory abstraction, second, protection isolation between processes, and third, eff- efficient memory allocation. So paging remains the backbone of modern memory management that enabling efficiency, virtual memory abstraction, the first one, and then the second one, isolation for the critical for security and multi-process system. And third one, scalability supports application from IoT to data center. So looking ahead, while challenge like TLB research persist, innovation in hardware and NVM and algorithm ML will redefine paging's role in the era of heterogeneous computing. So challenge remains page faults like TLB misses, but ongoing research continues to optimize performance. Future advancements in hardware and algorithm will feature refined paging for modern systems. As computing demands grow, so most of our solutions. Let's collaborate to build memory systems that are faster, safer, and ready for the future. So, the future of paging lies at the intersection of OS innovation and hardware co-design, ensuring in the era where memory management is invisible, instantaneous, and invulnerable. Thank you, and that's all for paging concept for our group. Thank you.